Welcome to this channel. In the previous videos we have discussed about Arrhenius concept and Lowry-Bronsted concept of acid and base. In this video we are going to discuss about the Lewis concept of acid and base. What is Lewis concept? According to Lewis concept, the acid is a species which accept an electron pair. Base is a species that donate a pair of electron pair. So it is also known as electron theory. So the acid-base concept is explained by means of an electron. So any species which can donate a pair of electron to the another substances, they are called Lewis base. For example, ammonia is a Lewis base and boron trifluoride is a Lewis acid. Let us consider the reaction between boron trifluoride and ammonia. Boron trifluoride, ammonia. So there is a reaction. So ammonia donate a pair of electron to this boron. So ammonia behaves as a Lewis base and boron trifluoride behaves as Lewis acid. And there is a bond is formed between nitrogen and ammonia, and boron is coordinate covalent bond. So this is a coordinate covalent bond. The arrow indicates that the electron comes from nitrogen to boron. Okay. So why it is called electron deficient? This boron trifluoride has vacant 2p orbital to accept the lone pair electron donated by the ammonia. So boron trifluoride, it has 6 electrons only in the outer shell. So the vacant 2p orbital, the electrons donate. So in the vacant orbital, the electrons are donate. So the reaction between boron trifluoride and ammonia. Ammonia donate a pair of electron. Boron accept a pair of electron. So it is Lewis acid and it is Lewis base. Why this boron accept a pair of electron? Because the boron has vacant 2p orbital in this outer shell. So the ammonia, the nitrogen can donate a pair of electron to this boron. So because of this vacant shell, it is electron deficient. With the excess of electron, it is electron pair donor. Okay. So the product is addition product, and the bond between the Lewis base and the Lewis acid is denoted by coordinate covalent bond. Coordinate covalent bond. Here the electron comes from nitrogen to boron. So boron trifluoride is a Lewis acid, it is an electron acceptor, and ammonia is a Lewis base, it is a electron donor. Okay. Then which of these substances act as a Lewis base and a Lewis acid? See, the substances which behaves as Lewis acid and Lewis bases are. Lewis acids are electron deficient molecules. So in these molecules, electrons are deficiently placed. That is aluminum trichloride, boron trifluoride, etc. And Lewis bases are molecules with one or more lone pairs of electrons. We have studied what water molecule contains 2 lone pair of electrons. So it behaves as a base. And all metal ions are atoms. All anions behaves as a base. Molecules that contain a polar double bond, for example, carbon dioxide contains C double bond in character, so it is a behaves as acid. But in case of unsaturated hydrocarbons or alkene behaves as a base. And molecules in which the central atom can expand its octet to the availability of empty d orbitals. We will see the examples. Behaves as a Lewis acid. And bases, the metal oxides behaves as a bases. Carbonium ion, the positive charges are carried by carbon atoms are called carbonium ion. So they are act as a Lewis acid. And the carbene ion, it is a negative species. The carbon carries negative charge, behaves as a Lewis base. Okay. Classify into Lewis acid and Lewis base. The first one is carbon dioxide. Carbon dioxide, the structure itself has a polar double bond, so it is Lewis acid. And next one, potassium oxide, it is a metallic oxide. Metallic oxide behaves as Lewis base. Boron trifluoride structurally, it has 6 electrons in the outer shell. So boron atomic number 5, so outer shell consists of 3 electrons. Fluorine atom has 3 electrons and total electrons are 6, and so it is electron deficient. Electron deficient species behaves as Lewis acid. Okay. Next one, ethylene. CH2 double bond. Ethylene has non-polar double bond. So organic compounds containing multiple bonds behaves as Lewis base. It gets donate a pair of electron to the other species. And silicon hexafluoride. Silicon atomic number 14. So the electronic configuration will be 1s2, 2s2, 2p6, 3s2, 3p2. So the third level, it has d orbital with the empty 5 orientation. So when bond formation, the silicon has able to expand the d orbital. So it can accept the electron. So it is Lewis acid. Silicon hexafluoride behaves as Lewis. The next one is water. Water structurally, it has 2 lone pair of electron. So the species behaves as Lewis base. Next, the seventh one, silver plus, Ag plus. So it is a cation. Cation behaves as Lewis acid. Okay. Next one, Cn minus. Cn minus behaves as Lewis base because it is anion. Okay. The next compound is ethylamine. What about ethylamine? Ethylamine, it is similar to ammonia. So instead of one bond, the ethyl group is there. The ET group. Yes, lone pair electron. So it behaves as Lewis base. Okay. The last one, CH3 plus. CH3 plus, it is positive charge in the carbon ion. So it is also known as carbocation. Carbocation behaves as Lewis acids. Clear? Evaluate yourself. Identify the Lewis acid and the Lewis base in the following reactions. Calcium oxide. Calcium oxide is a Lewis base because it is a metal oxide. Calcium oxide is a metal oxide, is a Lewis base. And carbon dioxide is a Lewis acid because it contains polar double bond. So we have studied that the substance molecules that contain polar double bonds behaves as a Lewis acids. Okay. Next, the dimethyl ether. Dimethyl ether behaves as Lewis base. Why it is Lewis base? The molecules which contains lone pair of electrons behaves as a Lewis base. So, in the examples, molecules with one or more lone pairs of electrons behaves as a Lewis base. And so, dimethyl ether contains 2 lone pairs of electrons. So, it is Lewis base. And the aluminum chloride. Aluminum chloride is the electron deficient molecule. Electron deficient molecules in the outer cell configuration. Aluminum contains only 6 electrons instead of octet. And so, it is Lewis acid. Okay. So, the oxygen donate a pair of electron to the aluminum. So, it is indicated by coordinate covalent bond. So, dimethyl ether, it is a Lewis base. Aluminum chloride is a Lewis acid.